Welcome to the Tech Blog Writer Podcast, your guide to future tech trends and innovation in a language you understand. Now, over to your host, Neil Hughes.
Welcome back to another episode of the Tech Blog Writer Podcast, and a big warm hello to each and every one of you listening. And that means you too, Ian Parker, who listens on the tube each day as he commutes to the office in London, or so he told me in a recent email. So a big hello to you, Ian. Now, lucky for you listening, I am several episodes ahead because I did have to take a couple of days rest after having put in my back out recently. So I was feeling sorry for myself, and I think I've officially reached the age where I make noises before I sit down and when I stand up. You know the ones I mean. So just before I sit down, I'll find myself going, when does that happen? It's just kicked in all of a sudden. But you didn't tune in to hear about how the ageing process affects a tech podcaster. You want to learn lessons from tech leaders. And let's be honest, they're far more interesting than me. So that is what you're going to get. And today I wanted to tackle the subject of the industrial Internet of Things and how it's showing no signs of slowing down. And it's something that many of you listening have probably never even thought about. The need for real-time data processing, analytics and rapid response, and how it's becoming a top priority across industries including oil and gas, wastewater, precision, agriculture and so many others. And meeting these priorities can be incredibly problematic through cloud-based service providers, especially in remote locations where internet connectivity is poor at best. Essentially, real-time data processing and analytics are a top concern for the industrial Internet of Things success. So the option of embedded intelligence and fog computing must be considered when the cloud is not fast enough. So if, like me, you're curious and enjoy learning about how technology is transforming industries that you don't necessarily associate with technology, you should love today's episode. Because I've invited Scott Allen from Freewave Technologies onto the show, and he's going to discuss how to scale intelligent networks and what software engineers should be focusing on when it comes to designing, developing, deploying and operating industrial apps in real time at the edge of the industrial Internet of Things networks. Whew, that was a mouthful. So buckle up and hold on tight as I beam your ears all the way to Utah so we can speak with Scott Allen, who's waiting to speak to us from Freewave Technologies. So a massive warm welcome to the show, Scott. Can you tell the listeners a little about who you are and what you do?
Sure. My name is Scott Allen. I'm the Chief Marketing Officer for a company called Freewave Technologies, based out of Boulder, Colorado. I've been in the technology business for over 30 years, and I've had tremendous influence in network performance, application performance, and security forensics. And now I'm doing industrial Internet of Things, remote radio communication systems, and application servers.
So you are working with some incredibly cool technology over there. And for people that are just learning about you for the first time, Freewave Technologies is a leading provider of wireless machine-to-machine solutions that deliver reliable access to data for leading companies in the industrial Internet of Things markets. So, like I said, I think most people listening will know all about the Internet of Things, but can you just help maybe set the scene and offer an overview of exactly what the industrial Internet of Things is and how technology is transforming areas that people don't necessarily think of or associate with high-tech technology?
Sure. Well, the industrial Internet of Things is just like the Internet of Things, except for it's for industrial environments. If you think about your home Internet of Things, you've got your doorbell answerers and your video cameras and all the things that tell you what's going on and alert you when people are at your door, et cetera, et cetera, et cetera. Well, if you think about in certain industrial settings, for example, oil and gas, where you've got a well pad out in the middle of nowhere or a tank that's full of valuable oil, they have some of the same basic issues. Who's going out to those sites? What are they doing out of those sites? What kind of data can they collect, and what kind of things they can do to monitor those sites? So they have very much the same kind of needs as we have in the home to keep our home safe and to keep it, you keep the fridge full and do whatever you're doing here. They have the same basic needs in some of these industrial environments, whether it's oil and gas or water, wastewater, or utilities or smart cities or grid systems or even things like earthquake monitoring and volcano monitoring. They're all gaining benefits from having technology identify what's happening at a particular site, who's at a particular site, and kind of what they need to do to improve a certain circumstance, situation, business circumstance, et cetera, at those sites. So the industrial Internet of Things is all about making sure that those devices and those environments are operating optimally.
So can you tell me a little bit more about where free-wave technologies fit into that emerging landscape? And I also believe that you're the number one provider of wireless industrial Internet of Things to the oil and gas industry too. Is that right?
That's correct. We actually sell to the top 30 oil and gas producers in North America, and we cover more than 60% of the top oil and gas producers worldwide. Essentially where we fit into that landscape is in the upstream environments. And when I say upstream, I'm talking about the places where they pull oil and gas out of the ground or out of where they actually pull the product out of the ground. In many cases, these environments are very remote. The weather can be either really, 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 really hot, like in Saudi Arabia, or really, 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 really cold, like in Alaska. So our technology, we basically have spent 25 years building out industrial grade radio communication systems specifically designed for those environments, for those really rough, rugged environments, and that's perfectly fit for machine-to-machine communication and now the Internet of Things for industrial environments. So we really fill in that real fog computing layer beyond where you cut off a Cisco switch and you have to go out in the middle of the Balkan in North Dakota or in Midland in Texas or up in Alaska where you've got to deploy really remote environments. But they still have to have that really good, solid connectivity to pull information about a sensor, to identify what kind of product you've got, whether a pump is going to break, what the level of the tank is, and measure and monitor and transmit that data back to a place where somebody can make a decision.
So real-time data processing, analytics and rapid response, it's got to be a top priority across all industries, including oil and gas, wastewater, precision, agriculture and many, many others. So how do you overcome challenges such as poor connectivity in these remote locations and rugged environments that you mentioned?
So we do several things. First of all, we do what they call frequency hopping spread spectrum radio. So we will take a spectrum, I don't want to get too technical, but we'll take a spectrum like in the 900 megahertz range, and we will take a packet that normally may not make it through, and we'll hop across multiple parts of that spectrum with a single packet to make sure that it gets across, number one. Number two, our newer technology, it's called ZoomLink, actually has some built-in technology and capabilities that provide a higher assurance that the packet doesn't get lost in the air, that it actually makes it to the other side. We call it Zoom Boost, and what it basically does, it has this feature called talk or listen before talk, so that it actually understands kind of where the other ZoomLink radios are talking, and it makes sure that it's transmitting at the quieter times. So that it ensures it goes through. We also do things like forward error correction, and we also do compression and packet aggregation as techniques to make sure that the packet moves from one side to the other. And we've been very successful in doing that. The second thing that we've done is we've added now edge-based application servers. We call it Zoom IQ, and that can actually be on the same device as the actual radio. So we actually are beginning to process information out in these edge networks, so there's less data that needs to transmit across the network. So we're making the networks more efficient so that there's a higher likelihood of being transmitted, and we're also reducing the redundant packets that have to come over with these application servers called Zoom IQ. So those are a couple things that we're doing that that really help help the quality and the resiliency of a remote network like we're talking.
So I was going to ask, what's the secret to scaling these intelligent networks? But assumingly it's this technology that you're building and using with your customers, is that right?
You got it, because to scale in these environments, you really need to think about a distributed compute environment. It's a combination of cloud computing from companies like Amazon AWS, which we are a partner with, and then distributed computing in the fog layer of these massive sensor networks that are in the middle of nowhere. So if I can distribute intelligence that into that SCADA or that sensor network, if you will, that actually do command and control and telemetry and make decisions locally, and then pass the changed information or the necessary information back to the cloud, where you have your big data and your predictive analytics and your global communication methodologies, then I really have a resilient, scalable scenario there. And we're working actively with a lot of different types of software companies who are now aggressively pushing their technology onto these application servers for just that purpose, to make that resilient, scalable network in these types of environments in an intelligent way.
Now, I'm glad you mentioned applications and application servers there. So if we do have any software engineers listening, what do you think they should be focusing on when it actually comes to designing, developing, deploying and operating industrial apps in real time at the edge of the industrial Internet of Things networks?
I think that's a really good question, because one of the critical things about the industrial networks that I'm talking about, now, of course, factory automation is somewhere we play too. But factory automation, you generally have more bandwidth available to you to deploy an application. So bandwidth is less of a concern. But when you get into these remote environments, your bandwidth is fairly limited. In fact, our fastest spread spectrum radio transmits at 4 megabits per second. So if you think about deploying an application in those types of environments, bandwidth is very precious. So developing an application that can efficiently use that type of network and that type of connectivity and bandwidth is critical, which basically means you only want to send data when you need to send data, when something has changed or something is updated. Unlike previous generations of this type of technology, it's called SCADA systems. Everything is a pull response. So every time a SCADA system would ask for something, the device would send everything back. So that's not very efficient, and companies want to do more with their networks than just pull data. Now they want to do things like video streaming. They want to put a video on a tank to make sure that somebody's not stealing their oil. And so they want to go beyond just monitoring the devices. They want to actually see what's going on out there, and they want to have things like man-down technology where they can understand if somebody's having a hard time. So they want to leverage that bandwidth in other ways than just monitoring a specific device. They also want to get the changes more rapidly so they can make better decisions on when they do a truck roll. I don't know if your audience is aware of this, but every time an engineer or a company has to do a truck roll out into these remote locations, it costs anywhere from $1,000 to $5,000 just to roll the truck. So reducing truck rolls or writing applications in ways to identify critical issues that require those truck rolls and give heads up to when a problem is likely to occur so they can manage the truck rolls better and make them more effective and efficient is really, really key for application developers to think about.
So many great points you're raising here. And like I say, a lot of them people won't know anything about. So what are your biggest challenges and opportunities right now? And equally the kind of problems and opportunities that people are coming to you with?
Well, I think that those, you're talking about problems and opportunities. One of the challenges that you face is, just like I mentioned, in these environments, these are rugged industrial environments. They're in the middle of nowhere. You need to have technology that can both work through, survive temperatures that are very, very cold in the wintertime and very, very hot in the summertime. So just the basic technology that survives the temperature range. And then on top of that, you've got to work in explosive environments. So you've got to be Class 1 Div 2 certified, Class 1 Div 1, ATEX certifications. So just the physical environment that we deal with is always an issue. designing radio networks so that they don't go down. Like you say, the resiliency and the uptime is really an area that we really try to focus on. Where the opportunities are really pushing that intelligence into these networks so that people can have better information and really become part of the Internet of Things age, if you will, so that things are done more proactively and actively. And with some real intelligence built into these networks, you could do that. And I'll bring up one other thing. The other side of our business, we do about 50% of our business in oil and gas. The other 50% of our business is really in unmanned systems, specifically, drones, air, ground, and sea. So another emerging opportunity for us is to build that intelligence into these unmanned systems so that they can act better in more autonomous situations. So, we've got things that do reconnaissance for military drones. In fact, we're in more than 30 military and defense platforms at this point in time. But we also do precision agriculture for, major tractor companies that do automated, farming and all that kind of stuff. So bringing that intelligence into those environments is one of the really nice opportunities that we have in front of us.
Now, despite these rugged environments and these temperatures and how they don't necessarily work with technology, the reality is, of course, is companies of all sizes and regardless of their location now have an insatiable thirst almost for information and real-time data. So how do you see that space evolving over the next few years as technology continues to progress and advance?
It's just going to replicate what it's done over the past four or 5 years in particular.
Yeah.
Over the past 4 or 5 years, that appetite for more granular data around what's changing in these environments has just accelerated beyond your wildest dreams. I mean, and that's going to continue. Understanding, what kinds of chemicals are in the soil so they can produce the right, so that they can produce the right yield, if you will. Understanding what needs to be watered and where. Understanding when somebody has come in and poisoned a water system. The data that's being required now is more granular, and it's all about what's changed and why it's changed and what do you do about it. Those are the things that are that's really the area for the industrial side of things on the Internet of Things that's really driving a lot of activity right now.
So what's next for FreeWave? Is there anything else that you can share with us today about the months or years ahead?
Oh boy, what you're going to see from FreeWave is a lot of activity around new types of applications. I talked a little bit about the monitoring application, that you deploy, but we also, for the first time in our knowledge, we've connected with a company called MCQ, and what they have is a video streaming application that we have deployed on this FreeWave Zoom Link radio with the Zoom IQ application server on it in a way that allows us to do video streaming over a 900 megahertz frequency hopping spread spectrum radio. Now, why is that important? I'll tell you one. I'll give you one use case. We're going to be deploying in a country in Eastern Europe for border security in an environment where they have no power. So basically, you're going to have solar panels with a battery pack and a Zoom Link radio and a sleepy camera that is going to be doing border control. When somebody comes across the border, the camera comes alive, begins recording the event, and transmitting that data live back to an operator that can make a decision. So that's the beginning of a brand new type of border security and surveillance, if you think about it that way. But it also applies to our traditional markets as well, when people want to understand when somebody pulls up to a gas tank or an oil tank in the middle of Nebraska and starts taking oil out. So I think you're going to start to see these types of technologies that are specifically designed for those remote environments, do video streaming, monitoring, and all sorts of other things. And that's what I can share with you today about kind of where we're thinking the future lies.
Fantastic. Well, a huge thank you for coming on today. But before I do let you go, could I just ask that you remind the listeners of where they can find you guys online, and also contact a member of your team if they have any questions about the conversation we started today?
Sure. You can see us at freewave.com, and you can just, if you want to contact us, you can look at just the contact us, and there's a whole list of folks that that are regionally located that you can contact, or you can call our headquarters in Boulder, Colorado, and we will direct you to the appropriate resource.
Well, speaking of you today, brought back a few flashbacks of my former life in IT, where I used to arrive in the middle of a field and an event manager would just want you to, I don't know, use some magic smoke and then create an internet connection in the middle of nowhere. That was challenging on its own, but I've never stopped to think about things like an oil tanker in Nebraska, the expensive truck rolls and rugged environments and the temperature. And I think it's real food for thought on what's going on out there, and also how technology is transforming multiple industries. And like we say, in the manufacturing and agriculture and industries too. It's amazing, it really is. So thanks for coming on today.
It's my pleasure. Thank you for your time.
I'll be honest with you, before today's episode, I had no idea how FreeWave has driven the industrial Internet of Things before that term even existed. For over 20 years, FreeWave have provided long-range, reliable and rugged wireless data links for energy, manufacturing, agriculture, utilities, universities and even the military. And I also didn't know that the company has millions of units in the field and has exceeded 2 million flight hours on leading military and defence platforms. That's what you call mission-critical wireless on every level. But what really excites me is how FreeWave is empowering organisations, both large and small, to get the data that they need and when they need it. It's no longer just about big data, it's about right data. That's what moves operations forward for any business. But I'd love to hear your thoughts about today's guest and the topics we discussed today. Before I spoke to Scott today, I had limited knowledge around FreeWave technologies. But I feel like I've learnt so much. But maybe you've got something that you want to add to today's conversation too. And that's what this daily tech podcast is all about. It's not just me presenting you with information or presenting you with a tech leader and his ideas or her ideas, but it's about sharing ideas and learning from each other. And that's why it's so important to me for you to be part of this conversation too. That was a bit Dead Poet Society, wasn't it? I was very close to standing on my desk saying, "Captain, my captain." But what I want is just for you to email me, techblogwriter@outlook.com, or tweet me at Neil C. Hughes. And if you have any cures for sorting my lower back pain that doesn't involve somebody walking across it, let me know that too. Right, it's time for me to take a Radox bath now and soothe these aching, ageing limbs of mine, but I'll return tomorrow. So thanks for listening, and until next time, don't be a stranger.
Thanks for listening to the Tech Blog Writer Podcast. Until next time, remember, technology is best when it brings people together.